Hello, everyone. I'm Marco Iorio. I'm working at Isovalent at Cisco, and today I'm with Arthur from Ledger to talk about multi-cluster networking with Cilium and MCS API. So let me jump right into what Cluster Mesh is. And in a nutshell, Cluster Mesh extends the Cilium data path and the Cilium functionalities you are used to a multi-cluster scenario. Speaking a bit about the architecture, the main takeaway here is that we have the agents which need to pull information from the other clusters. And they do this typically via the Cluster Mesh API server, which essentially provides a cached view of selected information from the Kubernetes API server of the other clusters. It synchronizes them into etcd, from which the agents can either directly pull or go through a cache, which is provided by KV-Store Mesh. So the main abstraction in the context of Cluster Mesh and in the context of multi-cluster services with Cilium is the global service. The idea is that a global service is a service which can load balance to backends which are spread across multiple clusters. And it's basically a normal service which exists identically in multiple clusters and whose behavior is controlled via annotations. Speaking of annotations, the most important one is the global annotation, which essentially has two meanings. On the one hand, it advertises the backends of the local service to the other clusters, and on the other, it enables the local service to load balance to backends which are advertised by the other clusters. Then you can tune a bit more this behavior via other annotations. One is the shared one, which essentially, if you set that to false, it allows to disable advertising your own local backends to the other clusters, but still use the ones advertised by the other clusters, as in this case by cluster 2. And finally, there's the affinity one, which you can set to either local or remote to favor the local or remote backends, as long as one of them is healthy, and then fall back to the others only if none of the preferred ones is available. So on the bright side of global services, they are straightforward to configure. You just create the services, apply an annotation, and that's done. They are fully integrated in Cilium, so they work with ingress, with gateway API, and so on. And they don't pose any overhead on Kubernetes. We are not creating any additional resource there. Yet, they also come with some shortcomings, and the most important one is that they are not a standard API, which means they don't really play well with some third-party software. So this is where EndpointSlice synchronization enters, and let me reiterate briefly on the why we do need this. So here we have two examples. On the left, we have the fact that global services historically didn't play well with headless services. And the reason is that headless services are a bit special, as core DNS is providing directly the list of backends rather than the IP of the service itself. On the right, we see that global services again, historically, didn't play well with Ingress and Nginx or other third-party Ingress controllers, so that they weren't actually benefiting from the remote backends associated with a given service targeted by the Ingress. So why aren't global services enough in this case? And the common denominator is that both these tools actually leverage the EndpointSlices to directly know all the backends rather than going through the service. And while Cilium knows internally about both local and remote backends, that's not the case for the EndpointSlices, which only include the local backends. So here is where EndpointSlice synchronization enters. And the idea is that the Cilium operator then automatically creates in the local cluster EndpointSlices targeting the backends which are in the remote clusters. This is a new feature available starting in Cilium 1.16. It's behind the feature flag, but then if you enable that, it's enabled by default for headless services, because that's required to make them work, and it's opt-in for all the other classes of services. The reason being that you may want to enable it if necessary, you may not want otherwise to avoid adding additional overhead on the Kubernetes API server. So let me jump right into a demo to show the behavior here. And we start with this a setup which has 3 clusters. We already have our application deployed. And we start by creating a global service which targets the Rebel base application. And here we see that, again, the EndpointSlices only mention the local endpoints. Cilium is aware of all of them. And indeed, if we try curling the service, it gets responses from backends from all the clusters. We now create an ingress using the ingress Nginx class, and we target again the same service, and we see that by default, we only get responses from the local cluster, even though the service is actually global. So we now enable EndpointSlice synchronization with the annotation again. We see that we get EndpointSlices from all the clusters, and now the replies come from all the clusters indeed. So finally, let's create also an headless service, targeting again the same set of backends. We see that now the EndpointSlices get automatically created for all the backends. And if we dig the service, then we can see that the list of backends returned includes both the local and the remote ones. So let me dig a bit into how all of this works under the hood. And this is the PR from Arthur, which introduced actually the feature. Architecturally speaking, the main difference is that now the operator also needs to know about the remote cluster information. And so it's also connected to the cluster mesh control plane logic. So reconciling EndpointSlices is actually a bit tricky. There's some caveats in the logic, which is fairly advanced, mainly due to batching and like splitting the endpoints in batches again. And the reason is they need to play well in terms of performance and scaling. And so why don't we reuse the logic which is already available there in Kubernetes? It's already there, so we could reuse it in this case as well. And that's what we did. It's obviously easier said than done. And the reason is that the main difference here is we are not actually retrieving information from Kubernetes, but from the cluster mesh control plane logic. And so we see here that the EndpointSlice controller is actually taking information from 4 different sources. Only the EndpointSlices come directly from Kubernetes via an informer, while all the others are sort of mocked informers which bridge the information from the cluster mesh control plane into the controller. There's also a bit of extra logic before and after processing the EndpointSlices themselves, so to make sure that everything plays nice with these adaptations. And with that, let me hand it over to Arthur to talk about MCS API.
So, if you remember, the title of this talk was Simplifying Multi-Cluster Networking with Cilium and MCS API. And we are finally getting to the MCS API part. But what is even MCS API? So the full name of MCS API is Multi-Cluster Service API. It's basically a standard that aims to extend the service, but across multiple clusters. It defines 2 new custom resources. One is ServiceExport. It's a very, very simple resources that tag a service of the same name as to be exported across clusters. And you also have the service import resource, which is a more complex one, but it is created for you. It aims to replace a service, but in a multi-cluster scenario. And finally, one last thing about MCS API is that the DNS domain won't be your usual cluster local domain. It would be clusterset.local, but we will see that in a bit. So MCS APIs on a high-level view looks like that. So you have a service export of the same name, so you tag it to be exported. And then there is something that takes all the exported services from all your clusters, merge it, and the aggregated resource with all those properties will be created into the service import resource, and it will be created in all clusters as long as the namespace exists. And this is super important because before we had to create the service manually, even if we were just consuming it without any pod backing it. So this addresses a major pain point into the usage of Cilium Cluster Mesh. And regarding DNS now, so here you see that the clusterset.local domain is mainly about the same as the cluster local domain. It is the exact same format as you see on the bottom of the schema. The other difference is that it will take its IP from the service import resource and not the service resource. And the IP can also be different across multiple clusters. Now for headless services, it works as you might expect, so exact same format of the DNS resource. And it returns the IP of the pods of every pods in your clusters. There is some particularities with stateful set now. As you might know, if you have a stateful set, the governing services of a stateful set can set hostname, and you can find that in DNS resources. And in that case, for the clusterset.local domain, we also integrate the cluster ID, so you really know that this is this exact pod, and there is no ambiguity of where that pod is, because bus 1 here could be in cluster 1 and cluster 2, but here you have the cluster ID, so you know. And I wanted to finish off this general MCS API presentation by shouting out all those amazing projects that integrate MCS API. It could be a full implementation or just third-party integration, like Gateway API, for instance. So you have many cloud providers and many other projects. If you are interested into MCS API, you can check those folks out. But we are at CiliumCon, and this is Cilium, right? So we will talk a bit more about Cilium specifically. So MCS API is supported as of beta state starting last release, so a couple months ago. This is the 1.17 release. And as you will see in a second, it takes full advantage of the existing cluster mesh infrastructure and features that Marco presented you. And so to install it, you need to have a cluster mesh ready, but also install the MCS API CRDs about service import and export. And the last annoying part is that you need to install the multi-cluster plugin in CoreDNS. This is a bit annoying because it's an external plugin, and as of every external plugin, you need to recompile CoreDNS, and we don't do that for you for now. But this is something that we want to address, mainly possibly by integrating this functionality directly into CoreDNS. We are already talking with the maintainers and doing that, but this might happen or not. We'll see. And now, regarding the hard part, which is, well, the implementation of it, this is, well, a schema representing the view of a local cluster, essentially. On the left part, you have how you get info about all your exported services. Basically, this will reach the cluster mesh API servers of the remote clusters. I can point it with the cursor. So here, And then we will gather info of the exported service in the local cluster mesh API servers. And then the operator here can basically read all the info from the remote clusters, but also from the local clusters via simply reading the Kubernetes API server. And then we create these service import resources, and we could be done with it because the service import is meant to replace a service. But here comes the tricky part, because we don't really want to replace every instance of the service import in the Cilium code base, because this is a major, major change. It will need to replace any load balancing logic, allocate a service IP, and much more. So what we do, and other implementation also does that, is that we create a DRI service. So this DRI service on the schema has a funky name because it's essentially a hash. So it allows you that the service name is exactly the same across all the cluster for given services, and it's also marked as global. So here now, magically everything should work because we have the service of the same name. We mark it as global, so everything cluster mesh related and service related in general is working. And we also can sync EndpointSlice with the EndpointSlice sync feature that Marco has presented you. And now the Cilium job is basically done. There is one more thing, though, which is the MCS Multicluster plugin that I was talking about earlier. And what it will just do is reading the info on the API server about service imports and the local EndpointSlice. At no point it will connect to remote clusters to get those info, because it's already all there in the Kubernetes API server, and it also something that we don't have to integrate into Cilium, so any implementation of MCS API can use those. And now we will finish the talk off by doing a small demo. So we have a few pods running. I didn't show it here, but we have two clusters with the same pods. And we define a very simple services here. It has nothing to do with cluster mesh, as you might see. And we also have ServiceExport. So we essentially export these services, and there's also a cool new feature in the next Cilium version that I wanted to show you here, which is that you can export labels and annotations. This is super, super useful because these annotation and labels will be able to get up to the service import, but also to the DRI service. So any annotation that can change the service behavior can go there. So for instance, there is the local affinity, here, or the sync EndpointSlice, or any other like layer 7 load balancing annotation in Cilium, and much more. So we are going to create those resources, and I'm going to show you what those look like. So here, the service export that we just created, there is some status here about if the export is valid or not. There might be some case where you export the service, and it has different properties across clusters, which will result in a conflict. And if that happens, it will show you here. And there is also the service import that is auto-created for you. And basically, there's a bunch of general info about the services. We also find the annotation and labels that I was telling you earlier that we export. And there is also all the lists of the clusters below that export this service. And we have the derived services, which is here. We also find the annotation and label that we were exporting. And this is the magic part. We have this global annotation. And basically, then it will work. There is also a tree of the resources here. So you see service import, DRI service, and the EndpointSlice. So basically what I was telling you about. And now we can show the IP. So here's the DRL IP, so 171. This IP is put into the service import. And if we do a DNS query over the clusterset.local domain, we find this IP. And we have also the same over the other cluster, but with a different IP, basically. Now, if we query these services, you see that you get answer from both clusters. So it essentially works. And it's over the clusterset.local domain. We can also do that via a gateway API. So here's the gateway API implemented by Cilium. And we define a super simple HTTP route that has a backend with the service import. Whoops. And we can apply this and query it. And yeah, we get answer from both clusters. So yeah, it works. And that's it for our presentation. You have a QR code on the top left if you want to give us feedback. And we can take any questions if you have any. Thank you.
Hello. Great talk. One question, does it actually work with other implementations of Gateway API, like Envoy Gateway class, for instance?
So that's a very good question. It actually relies on a annotation that is semi-standard. So it might not work with every Gateway API implementations. And also, if they rely on the service IP, it works. If they rely on the endpoint, it should support this annotation, basically.
Thank you.
Oh, no, sorry, wait. This, so I took the question in the wrong way. So it will work with every Gateway API implementation, but the opposite is not necessarily true. So yeah, it's complicated because there is the coupling. You can replace any MCS API implementation. And with this, the Cilium gateway might not work, but the opposite should not work. Well, it depends. Sorry. But it's written in the documentation.
Hi.
Yes.
How will it pan out if I have multiple clusters? Let's say if I have 20 clusters with the service export and the service import.
Sorry, can you say that again?
If I have 20 clusters and I want the cluster mesh with the service export and the service import, how will it pan out? Like, how will my setup look like?
Oh, well, you have your regular cluster mesh setup, and then you just have your regular service. You apply some service export, and then that's about it. You can query your service via the clusterset.local domain, and yeah.
And there is a cluster list that you provided with the list of clusters. So do I need to specify all the clusters there on each of the definition?
So right now, like if you specify a cluster export, that means that that's like a service export. That service gets exported to all the clusters. So right now, it's not like if you have multiple clusters, all the clusters will see, will get the corresponding service import. So get the possibility to access the service as long as the namespace corresponding to that service export exists.
I see. Thank you.
Thank you for the talk. How do you secure the link between different clusters when you use MCS API?
So essentially, it doesn't change anything in terms of how you secure the communication compared to normal global services. So the idea is you can use network policies. So network policies are cluster aware. And you can then configure, OK, I want this workload in this cluster to be able to reach the backends in the other cluster. Or you can, and then you'll be like preventing other clusters, for instance, to access the same backends. If you want to do like you have only a subset of clusters that can access that service. So that's for the like securing who can access what. And then, as Arthur was mentioning, so you can use IPsec or WireGuard as usual in Cilium so that you also secure the data in transit, actually. So that's on the other, from the other point of view.
Thank you.
Welcome. So I guess we have time for one more question.
Hi, thank you for the talk. I was wondering, how does Cilium handle the network policies, or if the Cilium network policy handle any like network security, because MCS doesn't say anything about the implementation of network policy.
So yeah, essentially Cilium implements policy based on the concept of identities, and identities are one of those types of classes of information that gets shared across clusters. And so they are essentially in different spaces. So you have the identity, which is scoped by ID of the cluster. And then, so you can write policies, as I was mentioning before, and use one special label which targets the cluster name. So then you can say, yeah, allow traffic to that workload based on the labels, plus one additional label which says this is the cluster. And internally at the data path level, all of this gets converted into this concept of identity, so a numerical identity, which, again, is sort of synchronized across all the clusters. So this is normal, like it works this way for pod-to-pod communication, for global services, and the same for MCS API. So MCS API builds on top of all the concepts that are already there for Cilium, essentially, normally in cluster mesh.
OK, thank you.
Thanks again, everyone.